This video is going to focus on how to divide complex numbers. And as you can see, based on what I have written down here, there's going to be three different parts to this video. First, we're going to talk about the conjugate, what it is, how to find it, and how we can use it to help us. Then we're going to talk about how to simplify problems that are trying to divide by imaginary numbers. So that means simplifying with I. And then finally, we are going to learn how to simplify division problems by using that conjugate we learned about in the first step. So a lot of stuff going on. Make sure you're paying attention and hope this helps you. Let's get started. So to start off with, we're going to talk about what the conjugate is. Conjugate is basically just an alternate version, or I should say the opposite version in some cases, of our general formula. So remember, the general formula for complex numbers is a plus bi. If I wanted the conjugate of this form, well, it's really simple. A minus bi. All we are doing is flipping the sign. We had plus before, we have minus now. That's it. That's the conjugate. So if I had something like, let's say, 5 minus 2i, my conjugate would be 5 plus 2i. All you have to do is change it from plus to minus, or from minus to plus. That's the whole concept behind a conjugate. Nothing else changes, just the sign for the imaginary number. Alright, now that we've got that out of the way, let's talk about simplifying with I. Sometimes you'll see problems that look like this. We have 3i over I. And you might be asking yourself, did I click on the wrong video? Because he's showing me fractions, but we're supposed to be talking about dividing complex numbers. Well, a fraction is division. This is saying 3i divided by I. And the way we handle this is not by just saying, oh, I'm going to cancel out my i's, and I just have an answer of 3. That's a nice easy way, but unfortunately it is not correct. What we need to do is, if we have top and bottom with i's, or more specifically, if our denominator has an I term in it, we need to change that. We cannot divide by just an I term. So what we're going to do is multiply top and bottom by I over I. Okay, I can do this because anything over itself is technically equal to 1. So what I can do is multiply 3i times I, and remember from the previous video that I times I equals negative 1. So I will have 3 times negative 1 all over negative 1. That means I have negative 3 over negative 1, whoops, not 3, 1, which becomes positive 3 over 1, which becomes just 3. Now you're probably saying to yourself, hey, right at the beginning of this example, you said we couldn't cross those out. You're right, I did. I lied. But I did that so that you would understand the concept of how we handle these. Okay? Because if I just said, oh, you can just cancel them out, you might try to do that every single time, and depending on what's on top or what's on bottom, that won't always work. So, yes, start off with, we could have just canceled out the i's and gotten 3, but then we wouldn't have learned all about this and how we need to multiply top and bottom by I to help cancel them out properly. Okay, now let's try another one. This time we're going to try and simplify 7 over I. And notice, this time there isn't an I term up here, so we can't simplify it the way we could have done the first example. So that means we're going to have to do the same method as before. We're going to multiply the top and bottom by I. We do this so that we do not have an imaginary number in the denominator, so that we are not dividing by imaginary number. So what does this become? On the top, 7 times I is just 7I. On the bottom, we have I times I. Well, remember, I times I is -1. So on the bottom, I just have -1, which means my final answer is just going to be -7I. And there we have it. We can simplify fractions or division problems that look like fractions by multiplying by I over I. Now, what if we have a little more complicated one? Let's get to it. Here we have the quantity 3 plus I being divided by I. And if your immediate thought is, oh, I'll just cross these out and get 3, you are absolutely wrong. We can only do that crossing out when there is an I to every single term on the top. The 3 does not have an I next to it, so we cannot do this. What we're going to have to do is, just like before, multiply the top and bottom by I over I. So, the bottom, that'll be the easiest part first. We're just going to have -1 on the bottom, because I times I is -1. And for the top, we're going to have to do some distribution like we learned about in our multiplying complex numbers video. So I have 3 plus I being multiplied by I. Okay, so we're going to distribute the I to the 3 and the I to the I. That's going to give me, well, 3 times I is 3I. And I times I is -1, so I'm going to have 3I minus 1. So we put that on top, and then because we're dividing by a -1, all the signs change, so our answer basically becomes -3I plus 1. And then we can flip this around to make it look more like our general complex format to be 1 minus 3I. And that's how we can simplify with I. Now we need to start learning how we can simplify our division problems using the conjugate. With this example, we have the quantity 2 plus 3I, and we're dividing it by the quantity 4 minus 5I. And we've been doing a whole bunch of examples where all we have to do is multiply the top and the bottom by I. Well, that worked before because there was only an I term in the denominator. This time we have a real term and an I term in the denominator, and if I multiply it by I, it's not going to get rid of the i's for me. This is where the conjugate comes in. So do not go towards this method if you notice your denominator has two terms where one is real and one is imaginary. We need to use the conjugate. And the conjugate that we are going to use is the conjugate of the denominator. So instead of multiplying by I over I, we're going to multiply everything by 4 plus 5I over 4 plus 5I. We are multiplying by the conjugate of the denominator, and this is going to get rid of the imaginary terms in the denominator and give us a simplified version in the top. It's going to take some work though, because if you've watched my multiplying complex numbers video, you know that when we are multiplying this kind of a number with this kind of a number, you're going to have to do some foiling or double distribution. So it's going to take some work, but we're up to the challenge. Let's get started. I'm going to start off by multiplying the top, and I'm going to write them down here in this magenta type color. So I've got 2 plus 3I times 4 plus 5I. Remember that we need to multiply the first numbers, the outer numbers, the inner numbers, and then the last numbers. So we'll start with the first numbers, 2 and 4, which gives me 8. Now I'm going to multiply 2 and 5I, which gives me 10I. So 8 plus 10I to begin with. Next, I'm going to multiply 3I and 4. 3 times 4 is 12, so we'll have plus 12I. And then lastly, we're going to have 3i times 5i. 3 times 5 is 15. I times I is negative 1. So we have a negative 15. And then we combine everything so that we have 8 minus 15, which is negative 7, plus 10 plus 12i, which is going to be 22i. So our numerator in this example becomes negative 7 plus 22i. And that's okay that the imaginary term is up there. We just don't want it in the denominator. Alright, now let me move this up a little bit. We got to multiply our denominator with its conjugate. And like I said, doing this is going to get rid of the imaginary term, which is going to allow us to get it into the form that we want in the end. So I have 4 minus 5i times 4 plus 5i. And just like before, we got to multiply the first ones, the outer ones, the inner ones, and the last ones. So 4 times 4 is 16. We've got 4 times 5i, which is positive 20i. We have negative 5i times 4, so that's negative 20i. And I think you can see how our i's cancel out now. And then we have negative 5i times 5i. Well, negative 5 times 5 is negative 25. I times I is negative 1. So negative 25 times negative 1 is positive 25. So we get plus 25 here. And what happens? Well, I've got a 20i and a negative 20i. These are going to cancel each other out. And I'm left in the denominator with just 16 plus 25. So that's going to give me 41. So my denominator ends up being 41. If you go through this process by multiplying by the conjugate and your denominator does not end up being a real number, you've made a mistake. Go back, figure out where it happened. But our final answer here, when we've simplified, is negative 7 plus 22i all over 41. And there we have it. That's how we can simplify division problems using the conjugate. Hope you found this video helpful. Rewatch any parts that you may struggle with, and good luck.